Okay, we have more polynomial division, but in this case we're going to use the synthetic division method. The reason that we can use the synthetic division method is because our divisor, right here, has a degree of 1 and it has a leading coefficient of 1 also. So if we didn't have those, we would have to use long division, but it is a degree of 1 and a leading coefficient of 1, so we're going to set up some synthetic division. Alright, when we set up synthetic division, we take the coefficients of the dividend. Oh. Sorry, I had my eraser tool on. We take the coefficients of the dividend and put them all in a row. So the coefficient of this term, 1, coefficient here, 4, coefficient, -4, next coefficient, -14, next coefficient, 12. Then we're going to make a little box over here, and what we put in the box is whatever our divisor is, we're going to take the opposite sign. So it's +2, we'll put in our box -2. Okay, now let's start the process. The very first thing we do is take that first number and bring it down. Then we take 1 times -2, and we get -2, put it over in the next column. Now we combine 4 plus -2, 4 plus -2 to give us 2. Then we take this 2 and multiply it by the -2 in the box. That's -4, and we place it right here. -4 plus -4 is -8. Then we take our -8 times the -2 in the box, which gives us +16, and place it right here. -14 plus 16 gives us 2. So we take our 2 and multiply it by the -2 in the box. That gives us -4. 12 plus -4 gives us 8. So this line of numbers is actually our coefficients to the quotient. Look back to the original dividend. We had an x to the 4th term. So that means this term is going to be our x cubed term. We're going to reduce this number 4 by 1 when we write our quotient. This is our x squared term, our x term, our constant term, and this term over here is going to act as our remainder. So when we write this, our coefficient is 1, our term is x cubed, we're just going to write x cubed. Next, our coefficient is 2, x squared. Next, the coefficient is -8, x, and our constant, +2. Our remainder we're going to write as 8 over our divisor, our original divisor, x plus 2. And there's our final answer. Now we want to look at this problem. It has a slightly different thing that we've got to remember to do in this. But again, our divisor is first degree and has a leading coefficient of 1, so it's okay for us to use synthetic division. What we have to remember to do in this case is put a 0 placeholder for our missing term. What do I mean by missing term? Well, we start with an x cubed term, and then we skip all the way down to an x term. We're missing our x squared term. So we've got to put a placeholder for our x squared term. The coefficient of our x cubed is 1. The coefficient for our x squared term, because there is not one, is 0. The coefficient for our x term is 7. And then the coefficient for our constant term is 9. Now what do we put in our box, which I barely left enough room for there? Whatever the opposite is in our divisor. So we're going to put -3. Okay, to start, we bring down that first number straight down below the line. It's 1. We take that 1 times -3. It is -3. 0 plus negative 3 gives us negative 3. We're going to multiply this negative 3 times the negative 3 in the box to get positive 9. 7 plus 9, 16. Then we multiply 16 times the negative 3 in the box, and we get negative 48. Negative 29 plus negative 48 is negative 77. So these numbers are the coefficients in our answer. It's not the answer, but it's the coefficients in the answer. Remember, we started with an x cubed term, so we're going to start our quotient one lower with an x squared term. The coefficients of our x squared term, that'll be an x squared, this will be an x, this will be the constant, and this will be the remainder. Coefficient of our x term is going to be minus 3x, constant, plus 16, and then our remainder, minus 77 over our divisor, x plus 3. So that's our final answer.